Assalamualaikum, my name is Izri Azim by Azizul. My metric number is 01 DKM2 F1121. So today I want to present about steam power plant, a vital energy source. Steam power plant play a crucial role in electricity generation, providing reliable and efficiency power for industry and communities worldwide. This plant convert thermal energy from fuel like coal, natural gas or nuclear source into mechanical energy through a complex cycle of steam generation, expansion and condensation. So next slide is understanding the steam power plant cycle. First is combustion. The fuel such as natural gas or nuclear fuel is burned to release heat energy. Second, it goes to steam generation. Heat from combustion is used to convert water into high pressure steam in the boiler. Third is turbine expansion. High pressure steam expands through the turbine, converting thermal energy into mechanical energy. Fourth, condensation. Steam is cooled and condensed back into water in the condenser, releasing heat. And fifth is pumping. Water is pumped back to the boiler, completing the cycle and preparing for the next round of energy generation. That's all for me. I pass to my friend. Thank you.
Assalamualaikum. My name is Muhammad Adi Arento. My registration number is 01 DKM22F1045. Today, I want to present about the core component or the main component of a steam power plant. The first one is boiler. The boiler is the heart of a steam power plant, responsible for converting water into high pressure steam using heat energy from the combustion process. It comprises the network of tube and drum where the water is heated and vaporized. The second one is turbine. The turbine converts the kinetic energy of steam into mechanical energy, driving a generator to produce electricity. Steam expands through the turbine blade, causing them to rotate and generate power. The third one is condenser. The condenser cools the steam existing the turbine, converting it back into liquid water. This process releases heat to the environment and reduces the pressure of the steam. The fourth one is pump. The pump circulates water from the condenser back to the boiler, completing the steam power plant cycle. It provides the necessary pressure to move the water through the system. Before we move to the next slide, I want to add one more component that is not in the slide, which is the generator. In steam power plant, the generator is a key component that convert mechanical energy into electrical energy. After steam produced in the boiler drive the turbine spin the generator's rotor, which is connected to a magnetic field. As the rotor spins within a set of coils, it induces the electrical current due to electromagnetic induction. This generate electricity is then transmit through power line for use in home and industries. The next slide is safeguarding the boiler, inspection and maintenance. The first one is visual inspection. Inspectors visually examine boiler tube, drum and other components for sign of corrosion, wear and damage. The second one is eddy current testing. Eddy current testing detects flaws and defects in the boiler's metal structure, ensuring structural integrity. The third one is hydrostatic testing. Hydrostatic testing involves filling the boiler with the water under pressure to assess its ability to withstand pressure. The last one is ultrasonic testing. Ultrasonic testing uses sound wave to detect internal flaws and crack in boiler component, particularly well. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aminuddin bin Muhammad Zawahi. My metric number is 01DKM22F1044, and today I'll be discussing the differential of what fire tube and water tube. The first one is construction. For fire tube, hot gases flow through tubes surrounded by water. Meanwhile, water flows through tubes surrounded by hot gases. Next is steam generation. For fire tube, slower steam generation due to larger water volume. Meanwhile, for water tube, faster steam generation due to smaller water volume. Next is pressure. For what fire tube typically operates at lower pressure. Meanwhile, water tube can handle a high pressure, allowing for greater efficiency. And lastly, application common in smaller low pressure application for fire tube, and for water tube, ideal for larger scale power plant and high pressure application. Now I will discuss about heat saving instrument enhancing efficiency. Firstly is economizer. Economizer utilize waste heat from flue gases to preheat feed water entering the boiler. This reduces the amount of fuel needed to generate steam, improving overall thermal efficiency. Next is air preheaters. Air preheater utilize the heat from flue gases to preheat combustion air before entering the boiler. This enhances combustion efficiency and reduce heat loss, further improving overall thermal efficiency. And lastly is feed water heaters. Feed water heater use steam extracted from the turbine to preheat feed water, raising its temperature before it enters the boiler. This reduces the heat load on the boiler, improving efficiency and reducing fuel consumption. That's all from me, and I'll pass on to my friend Taufik.
Assalamualaikum and good morning. My name is Muhammad Taufik Hakim bin Dahrum. My metric number is 01DKM22F1046. I will be presenting regulations and safety procedures in a steam power plant. First, boiler code. The ASME Boiler and Pressure Vessel Code establishes design, construction and inspection standards for boilers to ensure safe operation. Next, occupational safety. OSHA regulations focus on worker safety and health, covering various aspects of steam power plant operation. Next, environmental protection. EPA regulations govern emissions from steam power plants, ensuring compliance with air quality standards. Finally, licensing and permitting. State and local authorities issue licenses and permits for steam power plants, ensuring compliance with safety and environmental regulations. Finally, sustainability in steam power plants. Efficient fuel usage. Steam power plants can significantly reduce the environmental impact by adopting more efficient fuel sources and optimizing combustion process. Next, emissions reduction technologies. Integrating advanced emission control systems such as flue gas desulfurization (FGD) and selective catalytic reduction (SCR) helps minimize harmful pollutants. Finally, waste heat recovery. Capturing and utilizing waste heat from the steam power plant cycle for various applications such as district heating or industrial processes enhances overall energy efficiency.